Hello students. Today we're going to be taking a look at section 14.6, equations of circles. The general equation for a circle is derived from using the distance formula, given the coordinates of the center of the circle and the measure of its radius. An equation for a circle with center h, k and a radius of r units is given by the following equation: x minus h quantity squared plus y minus k quantity squared equals r squared. So there's some pretty important components of this respective equation, and yes, it does stem from the distance formula. It also technically stems from the quadratic formula, which you can kind of already see if, let's say, x minus h was represented as a, y minus k was represented as b, and then r was represented as c. So a squared plus b squared would in fact equal c squared. It's kind of a neat connection to be made. You could also square root both sides of the equation and replace h and k with x sub 2 and or 1, y sub 2 and or 1, and then r with the letter d. So it actually looks like the distance formula as well. Okay, so for example, and we're going to highlight some of those components here. Actually, let's do that first. The components of h and k in the context of the equation will represent the center of the circle. Yes, it says it up above, but I'm going to highlight it where specifically you can see it in the equation. While r is the radius. And yes, r is squared, and h and k are embedded in x minus that quantity h, whatever that number is, but also y minus that k value. So let's take a look and apply it in this example. Graph the circle whose equation is x plus 3 quantity squared plus y minus 1 quantity squared equals 16. Okay, so x minus h, in the context of x plus 3, minus a negative 3 is the same as x plus 3, so your h value is technically negative 3, not positive 3. And then y minus 1, well, the formula actually speaks to y minus a number, which now we have as far as k. There it is, 1. 16 is the right side of the equation, which represents r squared in full. So if 16 is equal to r squared, the square root of 16 simply is your radius, so 4. So you've got h, you've got k, and you've got r. Knowing again that the center is at this value, negative 3 comma 1, this h value and k value, and you'll plot it on the xy axis in a moment. We'll take a look at it. And the radius of 4. So if you go to the left 3 and up 1, there's your center. And then from there, you go 4 units in every direction. So they went 4 to the left. You can do that, of course, knowing now what your radius is. 4 up, right, and down. So if you have those 4 points in addition to, of course, the circle, or the center of the circle, excuse me, you're able to graph the circle. So let's move on. It says find the coordinates of the center and the measure of the radius for each circle whose equation is given. Okay, so for the first equation, we've got our h value and our k value pretty much already established, as you see, and then the r value, we'll have to do some math where we'll square root 14.44, because that's r squared technically. So the center will simply be, now notice it's x minus exactly how the formula speaks to, so 7.2 is your h value. While your k value, it's not y minus, it's y plus, so that ends up being a negative 3.4. Remember, minus a negative ends up being positive in the context of the original equation, which in this case it is positive. So negative 3.4 would be your k value. R, we'll go ahead and take a look on the calculator, simply taking the square root of 14.44. That ends up being 3.8, which simply is your radius. You could do the same graphing process, kind of like what we saw up in the example above. Number 2, the center of the circle. Hopefully you would all agree. Here's h, here's k. H in this case, because it's plus a half, we're going to go with minus a negative, so minus or negative a half technically. While the K value is simply just 2. R squared is 16/25. This I don't particularly need a calculator to figure out, because if we were to take the square root of both sides of the equation as you see it, R would simply be what? Square root of 16 is 4, square root of 25 is 5. Easy enough. Radius 4/5. Moving on, let's do some graphs. Number 4. So first it says graph each circle whose equation is given, label the center and measure of the radius on each graph. So yet again, because they gave you the equation, which is great, we can highlight that the center of the circle would simply be 2.5 comma -1. While the radius of the circle, I will have an extra step here on the calculator to perform, in which I'll take the square root of 12.25. We do that, let the calculator do its thing, we end up with 3.5 for the radius. So that's the radius value that I'll be going up, down, left, and right in all directions, of course, from the center. So 2.5 comma 1, let's plot that, -1, excuse me, let's plot that first. It'll be roughly here. All right, and then if we're going to go up, down, left, and right, 3.5, that puts me, what, 1, 2, 3.5 here. Let's go 1, 2, 3.5 here, and so on and so forth. 1, 2, 3.5. 1, 2, 3.5. From here, we're pretty much good to go. We can graph our circle. It'll be easier if I use the shape tool, but I'll try to freehand this one. Some of my circles are better than others, but this one kind of just let be as is. Okay. Label the center and the measure of the radius. Here's the center, of course. Pick any arbitrary point on the circle. It doesn't have to be one of the 4 points that I chose. There's your radius. Yes, the radius anywhere you look is 3.5 units. Let's finish up with one more example. I do think that these problems are fairly straightforward in application. So I'm going to take a look here, a little bit of a different situation with number 7. Number 7 is interesting because you don't exactly see h right away, but it does exist if you think about what x minus h being maybe possibly 0, which is what the deal is on number 7. So 0 comma, in this case 2, would be your center. The radius, this is an easier one because what? 9 is a perfect square. So if you take the square root of 9, of course, you get 3. So the center of your circle is here, 0 comma 2. While we go up 1, 2, 3, down 1, 2, 3, right 1, 2, 3, and left 1, 2, 3. We plot all 4 points again plus the center. Let me try that shape tool. Why not? And that should hopefully dictate more simply. Try to go through every point here. What our circle and look like and take shape as. All right. So as you can see, I'm trying to be more accurate, and that's not too bad. All right. So that concludes section 14.6.